my friends, so as we begin this last part of our course, which is a continuation, if you will, of confidence intervals, I had a memory from a long time ago that I think actually sets the stage pretty well for this next step. Let's take a look.
'Twas a beautiful spring day outside the Rule household. I was having a nice game of catch with our son Max, when all of a sudden, out of the corner of my eye, a car ran a stop sign right across from us. I took off running down the street like Robin Williams in The World According to Garp. Caught up to the offending driver just as they pulled into the parking spot by their house, ran up to the car, rapped on the window and said, "Hey." "What?" they said. "You ran that stop sign." "That's the first time I've ever run that stop sign." "I don't recognize you. How long you lived in this neighborhood?" "I lived here for 6 months."
You're trying to tell me you've been in this neighborhood 6 months, and this is the first time you've ever run that stop sign. I happen to be here
To witness the single one instance that you decide to run that. Hey, where you going? I'm not done talking to you yet. Get back here.
Okay, friends, so what I love about that whole interaction, other than the fact that it happened, is that it paints the picture for us of the next topic we're going to get into, called hypothesis testing. Now, this is a natural extension of confidence intervals, and you'll see why as we go through today and the next day. But what happened in that interaction was a really nice kind of layout of some of the terms from hypothesis testing, which is the first hypothesis testing. Hypothesis is something you postulate, right? You have an idea about something, a hypothesis about something. There are actually two involved with this interaction. The first, when I rapped on the driver's window and said, "What are you doing?" And they said, "Well, I've been in this neighborhood 6 months and I've never run that stop sign." That's the status quo as claimed by the driver. That's is statistically known as the null hypothesis. Null hypothesis. In symbols, we use a capital H and then a little 0 for null. Null hypothesis. They want me to believe in that null hypothesis. They want me to believe that they obey, I'm going to put this in quotes, stop signs in my neighborhood. Now, the reason I say obey, they told me it's the first time I've ever run that stop sign. Now, what does it mean to obey a stop sign? Do you do the California roll through? Do you stop dead, look both ways? So what we're going to say is, by obeying a stop sign, we say that you stop with allowable variability on how we define stop. And I'm being intentionally vague here because I want to kind of frame this statistically, the idea of what that's going to look like in the next video. Okay. Now, I only observed them one time. I had one study out there playing catch with Max. And I had one data point. And my data point implied not that. My data point implied what's known as an alternative hypothesis, which is sometimes called H1 or sometimes called HA. Sometimes that's a 1 to follow the 0, I guess. I think I use A most often. If you see me write 1, you know what I mean. Alternative hypothesis. The alternative hypothesis is going to be the opposite of whatever the null is. They don't obey stop signs in our neighborhood. So the test that we do is supposed to guide us as to which one of those two things we should believe. The driver claims this, the null hypothesis, the status quo, the way it always is. My observation points towards that. Now, which one do I believe? And that's why this example breaks down a little bit, because the status quo wasn't really observed, it was claimed by the driver. But what I'd like to look at now are some actual published examples of these kinds of hypothesis tests and kind of how they shake out with the exact same terminology. Let's take a look.